Hi there and welcome to the Dryden Pool Academy session number 16. My name's Jimmy Lamb and I'm sales manager for Dryden Aqua. Now I'm running this session solo because this is largely applicable to the UK pool market. I don't mean the subject, I mean the presentation. But I'm sure that there's plenty of other territories around the globe that would have experienced Cryptosporidia problems in their swimming pool water. So what this presentation is going to cover today is how to prevent crypto in your pool. So we'll have a look at what is Cryptosporidium and what is cryptosporidiosis. Have a little look at some outbreak cases. This is UK based. We'll have a recap on the biology in swimming pools, how bacteria survive, how our technology can help to prevent crypto. That's using AFM filter media and the complete DAISY system and what are the benefits. We'll have a look at the filtration performance of AFM compared to traditional means of filtration. And then really how we help to reduce your carbon footprint and how commercial pool operators can literally save thousands of pounds or euros by switching off their medium pressure UV systems and employing our Advanox advanced oxidation technology. So I'll explain how that works and the costs, or the running costs involved with that. Okay, so what is Cryptosporidia? Well, the Pool Water Treatment Advisory Group, PUTAG, in the UK, have this written in their standards. Cryptosporidia is a protozoan parasite and multiplies in the gut of humans and other animals. The life cycle stage that is shed in feces, I know it's not a pleasant subject, is called an oocyst. And people become infected when they swallow these oocysts. One single oocyst is enough to make someone ill with cryptosporidiosis. Now this is an important figure to remember because the oocysts are about 5 micron in size. That's the average size of one of these parasites. So just remember that figure as we go through the presentation. The PUTAG guidance goes on to say that cryptosporidiosis is the illness caused by the infection with Cryptosporidia. And anyone can get this, but it's especially common in younger children. And the main symptoms are watery diarrhea. I hope you haven't had your tea just yet. Abdominal pains, nausea, or vomiting, and a low-grade fever. And people that might swallow these oocysts when they have close contact with an infected person or animal and their feces through eating contaminated food or swallowing contaminated water. And most people become ill 5 to 7 days after ingesting the parasite. So sometimes it can be quite difficult to actually trace where the infection has come from. Symptoms typically last up to 2 weeks, but sometimes longer, and may come and go before full recovery. People with weakened immune systems have serious and possibly life-threatening illness. So it's really quite a serious problem that can be experienced by pool operators. I did a bit of research, turned to Dr. Google to try and find out a little bit more information. And I came across this study, Guidance for the Investigation of Crypto Linked to Swimming Pools. This was put together by Public Health Wales in conjunction with Public Health England. And as I say, it's the guidance for the investigation of Cryptosporidia linked to swimming pools. It's quite an interesting document. It goes on to tell us this study that was carried out, I know it's some time ago now, between 2009 and 2017. There's 2 different types of Cryptosporidia that we can experience. The first one is coming from animals, largely. This is Cryptosporidia parvam. And the one that's more prevalent in pools is the Cryptosporidia hominis from humans. And you can see on the findings of this report that the large majority of outbreaks are assigned to recreational waters. In fact, 52 outbreaks. And 48 of those were actually in general swimming pools and a few in hydrotherapy pools. Baby swimming pools, I was quite surprised. I thought that would have been a higher association with Cryptosporidia outbreaks, but only 2 in this study, and then outdoor paddling pools. Now, it seems we're not getting any better at protecting ourselves from Cryptosporidia during the course of the period of 2009 to 2017. The outbreaks have been, in fact, worsening by the look of it, although 2017 wasn't so bad. The guidance goes on to tell us that the problems have been contributed to outbreaks of cryptosporidiosis due to these factors, so inadequate pool design and construction, including water features. Sewage cross-connection is a curious one. Not quite sure how that can happen. It makes you think that sometimes in some places when they flush the toilet, it's going straight into the swimming pool. I certainly hope not. Fecal release or contamination from bathers, maybe not showering properly and cleaning themselves in all areas before they enter the pool. This is probably quite a common one, I think, in the UK. Excessively high bather loads. Pools are often oversubscribed to the design criteria that pool has been designed to. Inappropriate handling and disposal of stools when there's been a fecal release in the pool that the pool operator knows about. Are they dealing with this appropriately? Inappropriate response to fecal accidents, so even knowing that there's been a fecal release in the pool. This is where we really come into our own. Inadequate pool water circulation, coagulation and filtration. We know that some pools out there aren't even using a flocculant coagulant, for example. And another common problem that we're very aware of, particularly in the UK, is filter backwashing problems and inappropriate backwashing procedures. Filters aren't being backwashed at high enough velocity to evacuate all the debris that's been trapped in the filter, and they're not being done backwashed on a regular enough basis. And then the last one there on the list is our secondary disinfection treatment with the use of ozone or UV treatment perhaps not working properly. I certainly know a lot of commercial pool operators are very tempted to switch off the medium pressure UV systems, for instance, because of the excessive demand that they have on energy consumption. But we'll go into that a little bit later. Section 3 of this document goes into detail about swimming pool water treatment and quality, covering these subjects. So 3.1, basic principles of swimming pool water treatment, disinfection and efficacy against Cryptosporidia. You know, we know Cryptosporidia is immune to chlorine. It's a very hard-shelled parasite that chlorine simply cannot penetrate it. We know that bathers and bather numbers are often oversubscribed. The pool is being used outside of the design criteria, so there's flaws in the swimming pool design and circulation. And then the filtration, which is really what I want to hone in on this presentation. It goes on to tell us that the removal of these oocysts from pool water relies on good circulation, so that's moving that water from the main pool tank quickly through the filtration system, so that we can remove all particulates as quickly as possible and get that water treated with optimal filtration, coagulation, flocculation. So let's go back. Let's have a little reminder to ourselves of how bacteria survive in a pool. Because it's not a sterile environment, is it? There's always a level of bacteria in the water. And an indication of how effective our water treatment system is the results from our monthly microbiological tests. That tells us that the system we've got in place is adequate to control the level of bacteria living in the pool. So that bacteria that's in the pool, some of it can be killed quite quickly. It's quite a fragile organism. Some are a little bit more resilient and strive to reach a surface. And then once they find that surface, they then produce an alginate around themselves to protect them from the oxidizer, chlorine, in the water. And this is the early stage of a biofilm production, slime building in the pool. And we know that chlorine simply cannot penetrate, 100% cannot penetrate this slime buildup in the system. So it begs the question then, where are the available surfaces for bacteria to grow? Of course, there's the wall and the floor of the pool tank itself, and this is why it's important to brush the wall and the floor to keep that free of slime and build-up. There's the pipework, a little bit more difficult to reach. This is where chlorine dioxide treatments come into their own, a soluble gas which will lift and remove a biofilm. But the filter media itself, if we consider every grain of sand in the filter has a surface area and we multiply that up, if that filter has been designed and sized correctly, that will equate to well over 90% of the total surface area that the bacteria has got an opportunity to stick to and grow. And this is exactly what happens in sand filtration. Bacteria sticks to one grain of sand, produces the slime, which then sticks the neighboring grain of sand together, and eventually we get this biofouling within a sand media bed depth. Water's under pressure to pass through the media, and it starts to push these mud balls to the side, this biocoagulation, if you like, and the performance of that media starts to deteriorate. And we get channeling occurring. So particulate matter that we're trying to collect simply passes through, and occasionally we get a rupture of the biofilm bacteria flock back into the pool, and it destroys our oxidizer, our chlorine in the water. So the turbidity increases, the chlorine consumption increases because it's being consumed, trying to kill the bacteria in the system, and the filtration is no longer reliable. And this is why advice from PUTAG with sand filtration is to replace that media every 5 to 10 years. This is a great example of wormhole channeling in a sand media. And if you've ever had the pleasure of going out and doing media change, you'll know full well it's not the most pleasant job on the planet, particularly when you get down to the bottom of the filter, around the collection system, the nozzle plates, the laterals. This is really where we see a lot of biocoagulation going on, and it can be quite an unpleasant task. I do like the good use of PPE gear in this picture. Not. So, how can we help to prevent crypto? DAISY, Dryden Aqua Integrated System. As I said at the beginning, simply by swapping out your sand for AFM, which is 100% bioresistant. The bacteria in the system physically cannot touch and reach the surface of AFM glass filter media. So when you go back to the 90% surface area that I was talking about with sand, and you replace that with a material that's bioresistant, you start to understand how we can start to reduce the consumption of chemicals, chlorine in the water, because it's not having to fight against that biocoagulation in the system. How do we produce AFM? Well, it's produced in the world's most sophisticated and sustainable glass manufacturing process. We are literally taking bottles, beer bottles of all sorts, and any glass bottle, into the system from the recycling system. It goes into a hopper at the start of the process. We need to remove the paper labels, the metal enclosures, the non-ferrous materials through a process of magnets, suckers and blowers, plastics as well. We get all manner of stuff coming in with this recycled material. You would be surprised just what we receive. The plant in Switzerland is powered 100% by solar power. In fact, we overproduce, and the overproduction goes stored in huge Tesla batteries. Everybody here at Dryden Aqua who has a company car drives a Tesla. So when they come to work in the morning, they plug their car into the grid here at the factory. So we get free power for our car as well. We harvest the rainwater here. We use this rainwater to wash the raw materials. That sludge that's built up through the cleaning process is sent off for producing biogas. We have a zero waste policy. All the byproducts that are produced through the cleaning process goes back to different industries. Clear glass, for example, doesn't make for very good filtration media. We send this back for producing whiskey bottles or medicine bottles. Ceramics go back to different industries. We then clean the dirty water that we've used to wash our raw material with AFM. And then that's a sustainable loop as well. So we've got enough capacity here to last for about 3 months without any rain. We then need to sterilize the glass. So it goes through a sterilized system to burn off any loose organic contamination to less than 10 grams per ton. So it's a very, very clean product. From there, we then need to sort out the particular material that we want, which is only the green and the brown glass. And in fact, AFM is made up of about 98% just green and brown glass. Why, you might ask? It's because the metal oxides that give the glass this color already has a natural bioresistance. So in the case of brown glass, this is a ferric oxide, and in the green glass, this is a chromium oxide. And the glass breaks in a slightly different way compared to that of window glass or virgin glass or clear glass. So it helps us achieve the right shape for good mechanical filtration performance. Talking of shape, this is where once we've got the green and brown glass, this moves into what we affectionately call the beast. Okay? And the beast is actually sizing and shaping the various grades that we want to produce. Typically 4 grades, grade 0, grade 1, grade 2, and grade 3. It's only the grade 1, grade 2, and grade 3 that we're using in swimming pool applications. Grade 0 is used typically in water treatment processes. Then this is where the magic happens. The final stage is the activation process, which anybody's welcome to come and view at our factory in Switzerland or up in Edinburgh. And this is a 3-step chemical and thermal process. And this is where we change the surface structure and the chemistry of the glass to make it 100% bioresistance. During each batch, whilst each batch is being processed, the computer will randomly send a bag to the quality control department for them to do some very basic tests to ensure that the product is still being produced to our specification. Every batch produced has a batch number. Everything is traceable with the date and the barcode on there. So don't just take our word for it. We've had the product independently tested by the IFTS laboratory in France. This is the known and trusted authority for testing different, the performance of different filter medias. And their studies tell us that a filtration velocity of 20 meters an hour, so commercial filtration velocities, AFM NG will remove 95% of particles down to 1 micron. This is probably a better way of understanding the results. So what you see on the left-hand axis here is the percentage of particle removal against the size along the bottom. And we have a number of different medias that have been tested here. The first one being AFM NG. And if we draw that line at 95% particle removal, you can see there's 95% of all particles being removed down to 1 micron. Sand was the next best media that was tested here, down to 20 micron. So think back a few slides when I was asking you to remember that figure of the Cryptosporidia oocysts at 5 micron. With sand filtration, these are just passing straight through a filter, whereas with AFM-NG, we are creating a barrier. We're capturing those Cryptosporidia oocysts before they're allowed to enter back into the pool, and then they can be gotten rid of through the backwash procedure. How does AFM Daisy compare to other options that are available on the market? Well, certainly in the UK, there's a big noise at the moment about ceramic membrane filtration. They're very much promoted compared against sand, but let's compare it against AFM and Daisy. First of all, with AFM, there's no need for investment in infrastructure. It's just a straight swap from sand to AFM. So the capex is very, very low compared to the ceramic membrane systems, which are generally quite expensive. Low operating costs with AFM Daisy, because it's just a straightforward swap for sand. There's no additional maintenance requirements with this, as there are with ceramic membrane. Although they're promoted as being low op, I think long term you will find the operating expense will slowly rise. Life expectancy, well, we've had AFM in commercial pools in the UK for over 21 years now. I still think it's early days with the ceramic membrane filtration, but experience talking to others with the Dryden organisation, there are countries that have gone through that process, and ceramic membrane worked very well to begin with, but a lot of these sites have reverted back to media filtration since. Water savings, absolutely, because AFM backwashes so well, even at low velocities. Despite the myth in the UK that you need high velocities with AFM, AFM will backwash easily at 30 meters an hour if the system is restricted to that velocity. But we can come on to that later maybe. So we're typically seeing about 50% reduction in backwash time with AFM compared to sand. And it's certainly the case with ceramic membrane as well. There are water savings to be had with those systems. AFM, as I've already mentioned, is 100% bioresistant. We can't say the same for ceramic membranes. They are subject to biofouling and do need to be cleaned on a regular basis with cleaning solutions. However, the water quality for both systems is very, very good. Healthier bathing environment, yeah, this is because we're not producing such toxic chlorine byproducts. We've given the ceramic membrane a tick there, but if the system were to become biofouled, then you would get an increase in such byproducts. And under 1 micron filtration performance. The ones that I've seen in the UK are typically 3 to 5 micron. I haven't seen any under 1 micron filtration performance yet, but we've still given them a tick on that. Smaller footprint, I think this is where ceramic membrane really comes into its own, where there are access restrictions and the existing system needs to be replaced. Then ceramic membrane is quite a good solution because that can be built on site. You can carry the components through a standard doorway and build the system on site, whereas we do need to use the big vessels with Daisy. Other systems that are growing in popularity and promoted largely on water savings are regenerative media filters. Again, these usually come at quite a high capital expenditure, not so much of a low operating expense because you're having to recharge these systems with perlite or other powder substances that need to be disposed of and dealt with. So that can make them quite high maintenance as well. Again, life expectancy on these, we've put a question mark. I think it's still too early to tell. Yeah, they are promoted on similar water savings. They don't carry the bioresistance that we do with AFM. You can't use flocculants with these types of filters. So if you want to remove dissolved pollutants like phosphate, for example, it could be quite a challenge because you can't use a coagulant with these systems. It will just simply block them up, like with cartridge filters as well. Healthier bathing environment, yeah, again, I think because you're producing such good quality water. Under 1 micron filtration, questionable, certainly not with cartridge filters. But again, like with the ceramic membrane filtration, these regenerative filter systems do hold a much smaller footprint, so they do win over the Daisy system there. So. Just going to take a break and watch our movie, which promotes AFM and Daisy for commercial pools.
Running a commercial pool involves more than just maintaining clean water. It's also about ensuring efficiency, sustainability, and cost savings. Introducing AFM Activated Filter Media by Dryden Aqua. The world's most advanced filter media designed to revolutionize pool maintenance. Adapted to all sand filters without the need for investment in extra infrastructure. AFM is made from 100% recycled glass in state-of-the-art factories powered by self-generated solar energy. Our process uses 100% rainwater for washing, and every byproduct is recycled or repurposed, achieving zero waste manufacturing and setting a new standard in sustainable production. Through a unique 3-step chemical and thermal activation process, AFM becomes the only fully bioresistant filter media available, effectively preventing bacterial growth and biofilm formation inside your filters. This advanced technology keeps your pool safer by preventing channeling, unfiltered water, and harmful pathogens from entering the pool. By inhibiting biofilm growth, AFM also prevents the biological conversion of urea into ammonia, which is responsible for forming harmful trichloramines, the root cause of eye, skin, and lung irritation. This results in healthier air conditions for all pool users and staff. And there's more. Our activation process significantly increases the surface area of AFM and makes it hydrophobic, allowing it to filter much finer particles down to 1 micron and remove up to 50% more organic substances than sand and other filter media. This dramatically reduces water turbidity, lowers chlorine demand, and minimizes the formation of harmful THMs like chloroform, essential for protecting vulnerable swimmers such as pregnant women, babies, and children. But that's not all. One of AFM's most impressive features is its unmatched backwash performance. Unlike other filter media that struggle with clumping, biofouling, and poor bed expansion, AFM offers exceptional bed expansion during slower backwashes, and without biofilm buildup, it can efficiently clear over 95% of all trapped particles during shorter cycles as well. This efficient backwash process uses up to 80% less water than other filter media, saving thousands of litres each year. It's not just a win for your operating costs, it's a major win for the environment. And last but not least, AFM delivers outstanding value. With a lifespan of over 20 years, it far outlasts traditional sand filters, significantly reducing costs associated with replacements, maintenance, and disposal. Choosing AFM means more than just upgrading your filters. It's about investing in superior water quality, cleaner air, a healthier bathing environment, reduced costs, and a sustainable future. AFM by Dryden Aqua.
So, a new European norm, which is being adopted by the British standards, BSEN 17978 2024, was published in December last year. Now, this is a quality standard. We have the performance certification from IFTS, this time with the BSEN 17978. This is a quality standard, and it's for products used for treatment of water intended for human consumption and swimming pool water, glass beads and glass granulate. So what is it measuring? Well, first of all, it's measuring the total organic contamination. And this is a test that's done through loss of ignition. So an amount of the media is weighed, and then it's put into an oven, and it's cooked at a certain temperature, 550 degrees C, as you can see, and then it's weighed again afterwards. And the difference between the two weights is an indication of how much organic contamination has been burnt off. And that limit is set to under 300 grams per ton. So AFM is well within those limits, as I said earlier, at 10 grams per ton. It also measures the magnetic contamination, and in the contamination for these metals, it's a limit of up to 50 gram. But this is the really interesting one, and quite sophisticated equipment is required to measure this. And this is the over and undersize of each of the grades that we produce, so grade 1, grade 2, and grade 3. So the filtering grades, grade 1 is a tolerance of 5%. So if we're specifying a size of 0.4 to 0.8 millimeters in size, we can't go any more than 5% outside of that. And this is called the S-curve measure. And as I say, we use quite sophisticated equipment up in our R&D lab in Edinburgh to keep that in check. For the support grades, we've got a bit of a wider tolerance of up to 10%. The lifespan is a question that's often asked, and we've got AFM in situ at the Leisuredrome. This is a busy commercial pool just outside of Glasgow in Scotland, where they've been enjoying the benefits of AFM for over 21 years now. And I visited there a couple of years ago and met the technical guy there, Ian, and we did some analysis on the pool water, and we compared it to the incoming water. Now, bearing in mind, this is over 21 years now, the pool water was showing an NTU of 0.27 compared to the incoming water at 0.24. So very, very close to the quality of the incoming water. NTU is the measure of the turbidity, and the maximum acceptable levels in the UK is the same as drinking water, which is 0.5. So the higher the number, the more turbid, the more cloudy the water is essentially. So the water today, just as good as it was 21 years ago. So AFM, the most sustainable filter media for your pool. With AFM and APF, our coagulant flocculant, this is now what we call DAISY, the Dryden Aqua Integrated System. So this is the second step of the system. And once you've employed APF with AFM to make a DAISY, we improve the filtration further by a factor of 10, and we can achieve 0.1 micron, 95% particle removals down to 0.1 micron. So APF is not just a standard PAC flocculant. This has got 5 active components, coagulants and flocculants, and it's there really to remove dissolved pollutants that we need to pull out of solution into larger particles that we can then capture in the filter. And this is again reducing the oxidation demand, reducing the chlorine demand in the pool. So AFM, APF, removal of particles down to 1 micron. Everything that can be filtered out does not then need to be oxidized. And it's reinforcing and creating further a better barrier against these pathogens such as Cryptosporidia and even Giardia, which can be killed by chlorine eventually, but does take some time. So it's better to filter these pathogens out rather than to try and destroy them with high levels of chemistry. So the benefits of a DAISY system is to be able to filter down to 0.1 micron, so we are into the realms of ultrafiltration. We create that barrier against Cryptosporidia. We reduce the oxidation demand by up to 80%, significant chlorine chemical savings there. We have the clearest and safest water without pathogenic bacteria present. We have healthier bathing conditions without the production of the trichloramines and trihalomethanes in the form of chloroform. And we have the lower operating costs because we're reducing the water consumption, we're reducing chemical consumption, and we're reducing overall energy, we're creating overall energy savings. What we don't promise, however, is a reduction in your total combined chlorine. Why is this? Urea that's introduced to the water, typically from us as bathers, whether we like it or not, we're sweating and we're releasing urine when we're submerged in nice warm water. And 80% of that substance is in the form of urea. This is the perfect nutrient for bacteria in the system. But if urea remains in the urea form, it then reacts with chlorine to create an organic chloramine. When we have bacteria in the system, i.e. in a sand system, we've got a lot of bacteria in the system, so a lot of that urea is consumed by the bacteria and metabolized into ammonia. That ammonia then reacts with the chlorine to create inorganic chloramines. When we add DPD number 3 to our DPD number 1 test to give us our total chlorine, this is showing up all of these organics and inorganics. It doesn't differentiate between the two. So sometimes it needs to be dealt with. For example, in Switzerland, where I am today, public pools are regulated in so that they must not exceed a total combined chlorine level of 0.2. 0.2. We compare that to the UK, where our recommendations, not a regulation, our recommendations are to operate total combined chlorine of no more than half that of your free chlorine with an absolute maximum of 1 milligram per litre. So you can imagine what a struggle that must be for our Swiss friends. So we do have a solution. I would like to compare now medium pressure UV versus our Avanox system, because medium pressure UV is often recommended in the UK, first of all, to create a barrier against Cryptosporidia, because it will inactivate Cryptosporidia, but also to take out combined chlorines. But there is a side effect to that. With AFM DAISY, we create a barrier against Cryptosporidia, so it negates really the need for medium pressure UV. But we still get a build-up of organic chloramines in the water that need to be dealt with. So why is medium pressure UV so energy hungry? And why are commercial pool operators trying to find ways of reducing the use of medium pressure UV to make those energy savings? It's because it's producing quite a broad wave, a broad spectrum of UV light. And it's this broad spectrum of UV light that is very effective in activating Cryptosporidia, but also for removal of the combined chlorines. But when we've got organic compounds in the system, the UV, as these organic compounds pass through the chamber, are getting chopped up. It's not a complete oxidation process, it's a partial oxidation process. So a long-chained organic compound with a lot of carbons and hydrogens attached get chopped up into smaller molecules, being a methane, the smallest molecule, with 1 carbon and 4 hydrogens. This then reacts with chlorine in the water, where you get an atom exchange of 1 chlorine to 1 hydrogen to create a chloromethane. You get another atom exchange to create a dichloromethane. Guess what's coming next? A trichloromethane. And it's the trichloromethane that is the volatile one. This is the unstable one. And then through agitation of the water, this can be released into the aerosol in the form of chloroform, and this is what we're breathing in. So it doesn't really give for a very healthy bathing environment. Medium pressure UV reduces inorganic combined chlorine by photolysis. The monos, dis, and the trichloramine would be oxidized to nitrate. Well, nitrate is another source of food for algae and bacteria. So we don't really want these substances in our water. So medium pressure UV on the face value might look like a great solution, but you need to dig deeper and understand the byproducts that are being produced by such a system. A better solution is advanced oxidation, and this is where our Advanox technology comes into place. In partnership with UV experts Van Ramen, based in Holland, they produce this system for us, and it's in conjunction with the introduction of hydrogen peroxide. When you pass hydrogen peroxide molecules through an intense UV dose, you disrupt that molecule and you produce hydroxyl radicals. You basically split the hydrogen peroxide in 2 to create the hydroxyl radicals. These got exceptionally high oxidation potential. Any organics that come into contact with these hydroxyl radicals are 100% oxidized with no byproduct. The type of dose that we're talking about is 5,000 joules per square meter. So it's a very, very high intensity dose of UV radiation to split these hydroxyl radicals. Complete oxidation through advanced oxidation will remove substances that you wouldn't even know were present, substances that are coming from us, again, from pharmaceuticals or personal healthcare products. And I'm not even going to try and pronounce some of these substances, but you wouldn't even know that they were there in the first place. Why is Advanox better than medium pressure UV? Medium pressure UV are generating THMs in the form of chloroform, as just explained, and consumes about 50% of chlorine. So free chlorine that's passing through the chamber will also be photolyzed, reduced. The same thing can happen a little bit with Advanox, because we bring a little bit of hydrogen peroxide into the system, and that does neutralize a little bit of free chlorine as well. But I think the biggest one is the medium pressure are very expensive, not just in terms of capex, but also the operating expenditure. They've got that high power consumption, you know, very energy hungry. They produce a lot of heat, and the quartz sleeves tend to scale up over time, and they need to be cleaned with sophisticated automatic wiping systems. And they tend to have quite a shorter life, the lamps have a much shorter life expectancy as well. So I've done some analysis on the costs and compared the two with one another, and I just want to run through that with you, because this is really where we can save commercial pool operators significant amounts of money. If we take a typical 500 meter cube pool, the size of a medium pressure UV system for this type of pool, and I'm talking in pound notes here, sorry guys that are over in Europe or around the rest of the world, but it's all relative, I'm sure. The capital cost of a medium pressure UV is in the region of about £17,400. If we compare that to the Advanox system that would be required for that volume of pool, it's only £11,280. I've put the installation costs of each to be the same, but the reality is the installation of an Advanox will be quite a bit cheaper because we don't need the stainless steel fittings on the inlet and the outlet of an Advanox. That would, if we use PVC fittings on a medium pressure UV, then they obviously get destroyed by the intensity of the medium pressure wavelength. The size of the lamp differs between the two. So with the medium pressure lamp, we're looking at a 3 kilowatt lamp compared to a 600 watt lamp for the Avanox system. So this really starts to paint a picture of how we're saving energy with this system. Typical commercial cost for a commercial site per kilowatt hour for the electric is about 26 pence per kilowatt hour. And if these systems are running for 24 hours a day, the cost of running such a system per day is £18.72 for the medium pressure UV compared to just £3.74 of the Advanox. If that system is on 24 hours a day running all year, that adds up to just shy of £7,000 for the medium pressure system compared to 1,366 of the Advanox. Life expectancy of the lamps. The medium pressure is about 9,000 hours. With an Advanox, when you buy a system, you get a second lamp automatically, and each lamp lasts about 12,000 hours. So you've got 24,000 hours of lamp life with an Advanox system. So the number of lamps required per year, well, about one a year for the medium pressure, or not even half a lamp per year for the Advanox. Service and spares, because the medium pressure is usually a little bit more sophisticated, is that the right word? A little bit more complicated perhaps, with the automatic wiper systems. There's a little bit more service requirements there, so we've put a figure in of 1,900 compared to 1,250. I haven't just pulled these figures out of the air, by the way. I did consult with 2 installers of medium pressure systems to get some more accurate figures. Now, as I mentioned earlier, with Advanox, we do need to introduce hydrogen peroxide into the system, so we need to take the costs of that into account. The flow rate through an Advanox system for this size of pool is about 8 cubic meters an hour. So this is on a bypass. And incidentally, Advanox is also very effective at deactivating Cryptosporidia. Should anything pass through the DAISY filtration, which is very unlikely, and it enters the Advanox system, it would be deactivated. 8 cubic meters an hour of flow through the Advanox, so the dose rate of the 2 different strengths that are available on the commercial pool market in the UK is a 12% strength. That would be 240 millilitres per hour, compared to 80 millilitres of the 35% strength hydrogen peroxide. So over a year, that equates to 2,102 litres of the weaker solution compared to 700 litres of the stronger solution. So if we just concentrate on the stronger solution from this point forward, the cost per litre, and I've got this information from one of the biggest commercial chemical suppliers in the UK that we're working with, Brenntag, they would charge in the region of 84 pence per litre. So the annual cost for the hydrogen peroxide, again, is pretty insignificant in the grand scheme of things, only £588. And if they're operating that 365 days, every day of the year, that we throw that into the equation. So comparing the 2 CapEx, including installation for each of the systems, and then the running costs, you can see there are significant differences. So CapEx and OpEx. So for a medium pressure UV system, if you're considering investing in a medium pressure UV system, for that volume of water, you're looking in the region of 32,182 compared to investing in an Advanox system of 20,000 or just shy of 20.5 thousand pounds. So that's the saving in terms of the CapEx, 6,120. But the really interesting one is the annual savings. With Advanox, you're going to be saving, compared to a medium pressure UV system, just over £5,500 per year. So in the first year, you're saving £11,647. So if you haven't already got AFM in your filter, that saving is going to go some way to paying for that media and replacing it to sand. Because one thing I should add here at the end is Advanox is only suitable for use with AFM. Okay? Not to be used on a sand system. You won't get the same results. It's only there to complement an AFM DAISY system. Okay, so DAISY and Advanox is the best solution. This is the example of a 180 cubic meter pool here in Switzerland, 500 bathers a week. And this is where they had a problem with the combined, total combined chlorine being over and above 0.2. And DAISY and Advanox provided the best solution here. It's a much better and healthier than a public pool with medium pressure UV, because we're not producing those toxic chloroforms by partial oxidation. And it's as good as a public pool with ozone. Ozone was always seen as the best solution, produced the best water quality, but these systems, again, are very, very expensive, energy hungry, and very, very complex to maintain. So that brings us to the end of this session 16. Thank you very much for your time. Thank you for watching. Please refer back to our previous sessions on our YouTube site. We've got a whole array of different topics being covered there. Should you have any questions on any of the subjects that I've been speaking about today, you're welcome to drop me an email. You can get me at jimmy@drydenaqua.com. Thank you very much.